Alright, today we're going to be doing lesson 5-4, which is solving compound inequalities. This is probably something new, something that you haven't seen in 7th grade. So if you have any questions, please make sure you ask in class. So our objective is to be able to solve compound inequalities that contains the word and then also to be able to graph their solution set. We'll also be solving compound inequalities that contain the word or, and then also be able to graph their solution set. So let's go ahead and get started. Okay, so what is a compound inequality? A compound inequality just means that you have two inequalities. That's all it is. It's just two inequalities. So now you've got two different types of compound inequalities. You've got ands and you've got ors. First, going to start with and. So a compound inequality containing the word and is only true if both inequalities are true. So we're looking for the intersection of the two graphs. So looking at this first example, x is greater than or equal to 3 and x is less than or equal to 7. So let's first go ahead and draw on your number line, or draw a number line. And let's go ahead and number our number line. And we've got the numbers 3, 4, 5, 6, and 7. So the first one that I'm going to graph is x is greater than or equal to 3. So that's going to look like, and this is just my work, this is not my final answer, so I'm just doing it below. That's going to be a closed circle and the shading is to the right. So it would go like this. And then the next one is x is less than or equal to 7. So on the 7, that would get a closed circle and shading to the left. So now we're looking here for where do we have shading for both inequalities. And the only place where that is found is right here in between the 3 and the 7. So our final answer would be a closed circle on the 3, closed circle on the 7, and then shading in between there. Because our only shading is where both inequalities are true, and both of them are true between 3 and 7. All right, let's look at another example. Okay, looking at this example, notice that we've got negative 2 is less than or equal to x minus 3 is less than 4. This is an and problem. Whenever you see that it's all bunched up, it is an and problem. Okay, even though it doesn't say the word and. And notice on this inequality, we've got three sides. We've got a left, here's the left with the negative 2, the x minus 3 is the middle, and the right side is the 4. So normally we would get the x by itself. Well, that works true also in this inequality. So with the x we have a minus 3. So I want to add 3 to all three sides. You have to do it to the middle, to the left side, and to the right side. So now these are going to cancel out. And then we've got negative 2 plus 3, that gives us 1, is less than or equal to x is less than, and then 4 plus 3 gives us 7. All right, so this is what your answer would look like, your solution. Now understand that we have two inequalities here. Okay, I've got this one right here. 1 is less than or equal to x. But remember, we always want the variable in front. So I'm going to rewrite that as x is greater than or equal to 1. So whenever you're moving the variable in the front, remember you got to flip that inequality sign also. And then our other inequality that we have is right here. X is less than 7. So let's go ahead and graph that. So we need to have on our number line 1, 2, 3, 4, 5, 6, 7. And then looking here, 1 would get a closed circle, shading to the right, all the way that way. And then the other one, x is less than 7, that would get an open circle on the 7 and shading to the left. And remember, we are looking for just where we have both shadings, where the green and the blue both would be. So that means on 1, I would have a closed circle, on the 7, an open circle, and then shading right in between there. And that's the way the solution set would look like for an AND problem. All right, let's take a look at another example. All right, so for example 3, now we're going to be dealing with compound inequality that is containing an OR. And an OR statement will be whenever it is true, when at least one of the inequalities is true. And so that's the union of the two graphs. So let's go ahead and look at that. The first one we have here is x is less than 2. So if we were to graph that, let's go ahead and put our numbers on our number line. We're looking at 2 and 5. So I'm going to do 2, 3, 4, and 5. So now if I was to graph 2, it would be an open circle, and we would be shading to the left. And then let's go ahead and do the other one. We would get a closed circle because it's greater than or equal to, and then this one would be shaded to the right. So now that's just the work there. So now the real answer, it's where at least one. So that means it's not where both of them are. So that means we need to have it look like this. Okay, notice that this is very different from our AND problems. Okay, let's look at the next one. We've got 3 and 6, so I'm going to go ahead and on my number line, I'm going to number 3 through 6. 3, 4, 5, and 6. And let's look at the 3. The 3 is a closed circle, shading to the right. And then the 6 is an open circle, also shading to the right. So now for this one, we're looking where we have at least one shading. So where we have at least one, remember, at least means you can have one or more. So that would be here, closed circle, and then all the way to the right. Okay, let's go ahead and look at another example. Okay, example 4, solve and then graph the solution set. So an OR problem will always say the word OR. Remember, the AND doesn't have to say the word AND. It could be all bunched up. But an OR problem has to say the word OR. So the first thing we're going to do here is we're going to go ahead and solve these inequalities, just like you did last week. So we're going to get the x by itself here. So by doing that, we subtract 14. And that gives us x is greater than or equal to 1. Now let's do the next one by adding 9. Those will cancel out. We get x is less than, and negative 10 plus 9 gives us negative 1. So our answer is x is greater than or equal to 1, or x is less than negative 1. So on our number line, I'm going to make sure I've got negative 1 through 1. And then let's go ahead and do our work here. So the 1 is going to be a closed circle, shading to the right. And then the negative 1 is going to be an open circle, shading to the left. So remember, with the OR, you need at least one of the shadings. So we see that we've got one shading over here and one shading over here. Alright, so we will be doing more examples in class, more problems. And if you have any questions, please let me know. Thank you.